Today we will be presenting our final IoT project, which integrates the M5 Stack core device with the Blink IoT platform.
The goal was to design a system that is responsive, synchronized with the cloud, and is efficient on how it transmits data. The objective of this project is to design and implement a fully synchronized cloud-connected IoT monitoring and control system using the M5 Stack and Blink platform. The system must reliably perform remote alarm activation, RGB LED status control, and intelligently monitor temperature and humidity, while maintaining efficient data, communication, and real-time responsiveness. To the methodology of the hardware, it includes the M5 Stack, the HD sensor, and RGB LED module. A DHT11 sensor was used in this. It was connected to pin 17 to monitor temperature and humidity. And the RGB module was connected to pin 19, 21, and 22 for each colors. We also used the M5 Stack, built-in speaker, and physical button.
So for the software setup, it is mostly about setting up the Blink IoT system, the Blink cloud system. So as you can see on the board, switch widgets are utilized to control each component that are connected to the M5 Stack. So on the first row, we can see the switch widgets to control the alarm for the first task, including the other three widgets to control the LED. And secondly, the unit toggle for Celsius and Fahrenheit is utilized over here. And so a custom chart for humidity is seen over here to display the historical data of the humidity, and a real-time humidity value is displayed over here as well. And so numeric input widgets for maximum and minimum temperatures is also seen over here for custom task 4. So the first task is about implementing a cloud control audio alarm. The user must be able to control the beeping of the M5 Stack from both the switch widget and the M5 Stack. So alarm virtual pin is set to VIN 0, and when alarm is on, M5 Stack must beep for 5 seconds, once per second, and the Blink timer is used instead of delay to allow the device to complete scheduled events without interrupting the other processes. For the main commands used in task 1, the first command is the timer command, timer set interval. So it ensures that the beep function runs exactly once per second, where the rest of the code continues to execute smoothly. The second command is located inside the beep function. So this M5 Stack command generates a short non-blocking beep tone. And the third command is in the if loop. If button A was pressed, alarm on is equal to false, and the last line ensures that the app is never out of sync with the device state, even if the command comes from the physical hardware button instead of the cloud, ensuring that the cloud dashboard reflects the real status of the M5 Stack, which avoids miscommunication.
Now for task 2, the objective of this is to control the LEDs connected to the M5 Stack using the Blink app. When 3 switches manage each color of the LED, one color can be activated at a time. When turning on one, the other color will be turned off. For each switch toggle, use the designated color state to on or off. If on, the state and switch of the other colors will be turned off. Here's the code for red LED, for example. When V pin of the red is toggled, the red state will be toggled as the V pin. And if the state of red is on, it will turn blue and green off.
So the objective of task 3 is to create a smart sensor monitoring system that sends data to the cloud only when values changes by a considerable amount. Okay. So every 5 seconds, the device reads the temperature and humidity through the DHT11 sensor, through the 2 commands on the top, and the temperature value is sent when it is the first reading or when the temperature changes by more than 0.5 degrees. Like the temperature, humidity is handled very similarly, but with a different threshold, which humidity data is sent only if changes by more than 1%. Another key part of task 3 is the temperature unit switching from Celsius to Fahrenheit, and the user can do this by tapping a switch on the app and instantly toggle between Celsius and Fahrenheit. The system updates the label using the command update unit label, and then recalculates the display temperature from the stored Celsius value above. This is done without reading the sensor value again.
Task 4, our custom task. The user can set the minimum and maximum temperature in the big console. If the device detects that the temperature is out of the set range, it will flash red for high temperature and blue for low temperature. To avoid confusion between normal LED control and the alarm system, when the alarm system is activated, it will completely override the normal LED controls. And to the code, we added an if-else statement to the LED control. It compares the current temperature with the set temperature. If the current temperature is in normal range, the LED will be set to normal LED state as controlled by task 2. If not, the red or blue LED is be set to blinking state. The blinking state is controlled by this function right here. Basically, it just turns the state on and off. That function is controlled by blink timer, so it activates every half second. To the LED control, the first if is when the temperature is too high. The red LED will be set to blinking state, while blue and green will be set off. If the temperature is too low, the blue LED will turn to blink mode, and red and blue will be set off. And when the temperature is in normal range, the LED control will be activated as normal as the red, green, and blue state set in task 2.
To conclude this presentation, we have implemented a fully functional IoT monitoring and control system and a two-way interaction and synchronized operation between an F5 stack device and the Blink Cloud has been established, and we have designed a non-blocking alarm, an RGB panel, and a temperature warning system, and we have implemented an efficient temperature and humidity monitoring system using suitable change detection, and we've demonstrated real-world IoT principles such as user interaction.
To the reflection, we understood how to maintain state synchronization between hardware and cloud interfaces. Learn how to adapt and create more interaction between F5 stack and Blink Cloud. Gain experience from data filtering to remove sensor errors and reduce network traffic. Improve skill in structuring modular code and troubleshooting sensor inconsistencies.
Thank you.